Hello everyone. Today's topic is resistivity, also called as specific resistance. In our previous topic of resistance, we already understood resistance of a wire is directly proportional to its length. And second factor is resistance of a wire is inversely proportional to area of cross section. So R is proportional to the length of the conductor. R is inversely proportional to area of cross section of the conductor. Now I am combining these two equations. So I am getting R is proportional to L divided by A. Now I want to remove this proportionality sign. So I have to introduce a constant. I am introducing a constant called as specific resistance and L upon A as it is. What is this symbol called as resistivity or specific resistance? Now I want to frame this equation in terms of resistivity. So let us shift this length and area of cross section on opposite side. So I am getting my equation as RA divided by L. Name of this symbol is rho, RHO, and it is denoting resistivity. Now I want to define resistivity. So I'm going to take up area of cross section 1 unit and length equal to 1 unit. So what am I left out with in this equation? We are left out with rho, resistivity, it is equal to resistance. So now from this condition, we can define specific resistance or resistivity. See, looking at this, we can define specific resistance is equal to resistance of that wire of unit length and unit area of cross section. Now let us understand resistivity in a practical way. I have taken a wire, a long wire. Now I am going to cut a piece of wire which is having unit length and unit area of cross section from this path. So I have cut a wire of unit length and unit area of cross section. Now resistance of this full long wire is denoted by R, called as resistance, and resistance of that piece of unit length and unit area, it is called as specific resistance or resistivity. So resistivity or specific resistance is nothing but resistance only of that wire which is of unit length and unit area of cross sections. But we are calling it as specific resistance because we are being specific about length and area. So according to definition, specific resistance or resistivity of a material is the resistance of the wire of that material of unit length and unit area of cross section. Now let's give unit to that physical quantity. For that I am going to write its formula. Resistivity is equal to R A upon L. Now let's give unit to R. Resistance ohm, area meter square, division sign, length meter. So meter from here gets cancelled off and we are left out with ohm meter. So ohm meter is the unit of specific resistance. Now first let's focus on resistance factors and then we will go on to specific resistance factors. So factors affecting resistance are material of the conductor, length of a conductor, thickness, it means area of cross section of the conductor, temperature of the conductor. Now out of these 4 factors, for specific resistance we have already taken unit length and unit area of cross section. So these 2 factors are not affecting specific resistance. So which 2 factors are left out for specific resistance? Material and temperature. So for resistance 4 factors and for specific resistance material and temperature only 2 factors are affecting. Length and area of cross section we have set as unit. Now let's study all the factors in detail. Specific resistance is different for different substances. So first is material. Now let's compare. Specific resistance is very low for metals. Definitely because for metals we will have so many free electrons. Low for semiconductor. Semiconductor, its name suggests semiconductor. Number of free electrons are going to be less than that of conductors. So specific resistance is low and Specific resistance is very high for insulators because of negligible amount of free electrons. Next factor is specific resistance depends on temperature. For metal, we have studied when temperature increases, resistance increases. So specific resistance also increases because whatever amount of heat is supplied, it will be absorbed by electrons and they will start moving randomly. So definitely number of collisions will increase. So with increase in temperature, specific resistance increases. But behavior is completely opposite for semiconductors. The only reason is its construction. Semiconducting materials are such that if you go on increasing the temperature, specific resistance goes on decreasing. Now, for some alloys like constantan, manganese, specific resistance practically remains constant with a change in temperature. Actually, these alloys are made purposely so as to keep resistance constant with a change in the temperature. Let's go for the very important note. Specific resistance or resistivity is constant at a given temperature. That means if you change the length, if you change the area of cross section, makes no difference to resistivity. But in case of resistance, we observed stretching the wire or we are folding the wire, then we are changing the length, area of cross section, then resistance was changing. But for specific resistance, changes in shape and size makes no change in the resistivity of the material. Because of specific resistance deals with unit area and unit length. So, it does not depend on the shape and size of the conductor. Now, next topic is conductivity. While studying the topic resistance, we studied one more subtopic called as conductance. Same way, while studying resistivity, we are going to talk about its subtopic conductivity. Reciprocal of specific resistance, or you can say reciprocal of resistivity, is called as conductivity. It is denoted by symbol sigma. Conductivity is denoted by symbol sigma. As we have studied from the definition, it is the reciprocal of resistivity. So sigma is equal to 1 upon rho. If I want to frame an equation, then 1 upon, what is the formula for resistivity? R A upon L. So now if I am taking reciprocal, so what am I getting is L upon R A. So sigma is equal to L upon R A. Now I want to give unit to this physical quantity. So looking at the formula, we will give unit. Length is measured in meter, division sign. Resistance is measured in ohm and area is measured in meter square. So meter and from here meter gets cancelled off and we are left out with 1 upon ohm meter. So in other term, I can write ohm inverse, meter inverse, or we can write Siemens meter inverse. Now let's go on for the last subtopic named as superconductors. Now name suggests superconductors. It means such a conductor which is having very high conductivity. In our day-to-day life, to construct these superconductors is very difficult because of it cannot be manufactured at a normal temperature. A superconductor is a substance of almost zero resistance. It won't be exactly zero, but it will be almost zero resistance or infinite conductance. Now zero resistance means definitely its conductivity is going to be very, very high. So it is said infinite conductance. But it could be attained only at very, very low temperatures. That is nearer to 0 Kelvin. Not exactly 0, but nearer to 0 Kelvin. The example of superconductor is mercury. The condition is below 4.2 Kelvin. So it's quite a low temperature. And in our day-to-day life, to maintain this temperature is a real difficult task. Next is lead, below 7.25 Kelvin. It is also quite a low temperature. Third is niobium, below 9.2 Kelvin. So these are all the examples of superconductors. Thank you.